So you have just created your app and it uses API as part of the features, and you use some sort of AI vibe coding tool. And the app works perfectly fine. No issues, happy days, right? And then you notice as your user starts to increase, as you start to get more customers, your app starts to crash, your performance starts to slow down, and you're getting these security alert system. And that's because AI does not think about your app infrastructures. The foundation is so rocky, it is too vulnerable, and at some point you're going to have to go backwards and fix everything. And that becomes a major headache. I can tell you from experience. I've done this too many times, and it's just more important to set the foundation up early on than it is to set it later on. And I think too many apps out there are not addressing this issue, because it's easy to bypass this, and it's easy to say, let's get a working app and we'll take care of it later on. But if you can just address some of these fundamentals very early on, you will save yourself a lot of headaches. Now, I'm not saying there's anything wrong with using AI or vibe coding, but you kind of have to be the brain. This is what separates the seniors from the juniors. This is what separates from someone that's just new to vibe coding, someone that knows what they're doing with AI. And mostly when you ask AI to write your API feature, it will use something like this. It will use a simple fetch request, and this is just a normal JavaScript fetch request. There's nothing special about this, and most languages use something of similar syntax as this. And I think we need to firstly address what API is. So you make a fetch request like this, and this will be in your app, and you ask your app to fetch data from somewhere else, and that data is the API, and you're making a fetch request from the API provider. The API provider could be anyone. It could be GitHub, it could be Stripe, it could be from Google. But whatever you're trying to do, you need their data, you need their information in order for your app to do what it needs to do. So it will go ahead and create a fetch request like this when you ask AI to do it. But it's extremely simple. It doesn't think about other stuff. It doesn't think about the potential errors, the potential edge cases that could come along the way. And this is where you need to be the one that thinks about this. I always say this. You need to think of AI as your junior developer. It will do all the coding for you. It will write all the syntax for you. But you are the director. You are the senior. You are the boss. You will see everything that comes beforehand. And again, there's nothing wrong with AI, but AI will only do what you tell it to do. You have to tell it to think about scenarios. So some of the things you will notice is that when you first build your app and you tell AI to do it, it will work perfectly fine. But then it will come across something called the scaling wall, and it should look like this. So the scaling wall is something most developers know about. And say this is the graph. This graph perfectly illustrates what the scaling wall is. So the bottom line is you and your app, right? You're marketing your app, you're scaling your app, you're telling people about your app, and then this line, y-axis here, is the number of users. So as you market and your app becomes well known, the users starts to increase. So you start from 1 users, 2 users, 5, 10, 15, 20, 30, 50, 100, and etc. Now it depends on your app and how well it can handle the situation. But you will notice at some point it will hit the scaling wall. And the scaling wall is where your issues tend to occur. And it could be all kinds of issues. It's not necessarily one issue. It could be performance. Your app starts slowing down. It could be that your API provider is blocking you. Or it could be some sort of security warning or security breach. But you will notice that something happens and you're going to have to deal with this at some point. So when you hit the scaling wall, you're going to notice the 429 requests. These are the main issues that you're going to notice. The 429, too many requests, expose env keys or any kind of security breach, or the performance base. The loading is way too slow and you're getting customers constantly complaining to you. It's just not working the way it should be working. So this is where you need to start thinking about fixing these issues. And we're going to come to 3 common issues. And the good thing is that you don't need to code these things. Like, as I said, when I used to code back before AI, it was a massive headache. But now I just tell AI what to write and tell it what to do. But you do need to know the fundamentals. You do need to know this yourself. Once you know what you need to look out for, then you can just tell AI to do it for you and sort it out for you. So one of the first things that you need to look out for within your app is how resilient is your app, right? If you've got a low number of users, you really don't need to worry about this. Again, it really does come down to what your app is and what the API request is doing and how much usage your API or your app is getting. One of the most common things you'll notice is the 429 requests. And the 429 error is basically where you're making far too many requests in too short of a time span. So when you make a fetch request from the API provider, they will have their limits. And each one of them is different. Not everyone is the same. You're going to have to read the documentation, or you can just tell AI to do it for you. And you will find out that each API provider has a limit. Mostly, commonly, from what I've seen, and this is not a standard default, but this is what I've seen mostly, their limits tend to be between 100 to 500 requests per minute. So we're going to keep this simple for now. So say you make 100 requests from the API provider. If you go beyond 100 within that same minute, you're going to get hit with the 429 error, and it will say to you, it cannot give you the data you want, and you have to wait. And you have to wait for the next minute. And normally this is not an issue, but you have to deal with this if you have a high usage and high users within your app. So it should look like this. So it fails, then it will try. It will fail, then it will try to the API provider, and it will keep trying until it crashes. And this crash is normally blocked by the API provider. And they do this is because the API provider thinks you are a DDoS attacker. A DDoS attacker is something really bad, but it just thinks that you're some sort of hacker trying to break into their system. That's the simple version. But what you need to do is use a smart retry system. And the smart retry system should look something like this. This is how it should look like on the root. So this is the native retry. This is how most app will do it if you've not set this up. We need to set up the exponential backoff. And what it will do is set up the request. If it fails, then okay, it will just request it right afterwards. This is a normal fetch request. If it fails again, then we delay the fetch request. So instead of fetch requesting within 1 second, we might delay it for like maybe 3 or 4 seconds. If that fetch request fails, then we might delay even more. So we might wait 7 seconds, 10 seconds. If that fetch request fails, then we delay even more. By the time we do this, the minute will be up and everything should be working fine. This improves reliability, it's more stable, it's better for your performance, and most crucially, the API provider will not think you are some sort of hacker trying to break into the system, and it will not block you off. And this is the most important part, because the moment the API provider thinks you are some sort of hacker or some sort of DDoS attacker, it's going to block you off, and you're going to have to go back to them and you're going to have to prove to them that you're not some sort of hacker, and you're going to have to go through that whole system, and it's just a major headache. So it's better to set the system up from the very start, and this is what we call the exponential backoff. And just tell AI to fix this for you. That's all you got to do. And if you tell it to do it and it does it properly, you're not going to have to worry about this issue. So let's go back. So once you fix this issue, so we've sorted out the resilience and you use exponential backoff. Another issue you're going to come across is the performance base. Okay, so the performance is where your app is still working, the API provider and the fetch request is working perfectly fine, there's no issues there, but maybe you notice that the performance is dipping and it's really slow. And this is where you kind of have to look at the API provider and the data it's giving you. Normally AI would just fetch requests and it will fetch the whole data. But what if the data that you are fetching is so massive? Like maybe there's 10,000s of data information, maybe close to 100,000 information. And you don't want to start again. You want to get to a specific point. You want to get to a specific data. This is where you have to be smart about it, because you have to use pagination trap, and we call it the pagination. It's difficult to explain, but think of it like a book, right? You got your book and you read in your book, right? And you finish off at page 20. But then for some reason you had to take a break, right? And then you go back and then you come back and you read your book. Are you going to start from page 1 to 19 and then get to page 20? No, you're going to start from page 20 because you don't want to read page 1 to 19 again. That's just a waste of your time. It's the same thing with data. When something occurs, you don't want to start the data again, right? Imagine if it's just like between 1 to 10 data, then it's fine. But if you're talking about hundreds, maybe thousands of data, then you have to implement the pagination. And it's a must, because your performance is going to dip and the users will use it, especially if you have a lot of users using your app at the same time. So it should look something like this, right? This is your book. And normally, natively, your app will just read from 0 to page 20. But we need to set up a system where it starts from page 20. And I'm using page 20 as a book, but think of it as data, right? Now, each API provider has its own cursor. And when I say cursor, I mean, that's just a technical term where you start from a specific point within the data. So you need to tell AI, listen, we need to use pagination. We need to set that up, and we need to start from a cursor point of view. And in order to do that, you need to save the cursor. And it's a little bit more complicated to save it, because now you have to save the cursor point of view, but it is absolutely worth it. And most API provider will set up some sort of cursor point for you. So it's not difficult to do. So as you can see here, instead of having to read each data from 0 to 15 in this example, you can just tell AI, hey, listen, can you just start from cursor ID, starting after? And then you save yourself all this usage. You save yourself from reading all of this data. And it is a massive performance boost for your application. Okay, so the next one is security and fortifying your app with the backend proxy. So let me explain this part then. Right, so unfortunately, AI really is not great when it comes to thinking about security unless you specifically tell it to, right? And most of the time, if you're just creating a simple app or whatever app, AI is always looking for convenience, and that's something I've come to learn about AI. It just looks for convenience. It's not different from people, right? We want the easiest solution, but we also want it to work properly. So commonly, when you are using an API and you are fetching it from an API provider, the API provider will give you a key. This key is a secret key. This secret key is only for your eyes only and for your app only. It's for no one else. Maybe for your team as well. But besides that, it's for no one else. and you must protect your API key. And if you don't protect your API key, or sometimes it's referred as secret key, API keys, or keys, however, but it's all the same thing. And your API key is like the password. Like if you have an email, if someone knows your password, they can log into your password, they can log into your email, and they can get access to your email address. It's the same thing with API keys. You must protect your API keys, because if a hacker is able to access your API keys, that's a data breach. You are going to get in all kinds of issues with the laws, the legals, the user, even the API providers. So this is probably the most fundamental, I would say, that needs to be taken care of. Unlike the other two, where resilience and performance, this is security. This is the number one thing I think you must make sure that you prioritize. And luckily, it's not that difficult to do. The key concept is to never, and I repeat myself, never save your API keys on the front end, right? Unless it's a small app, there's no data breach, you don't care, whatever, it's a simple app, you don't give a damn, then fine, use the API key on the front end, it's not an issue. But the moment you are handling important data, sensitive data, you must, and I repeat, you must, I can't even tell you how much I need to iterate this, because I see this mistake being occurred too many times, and it shocks me even to this day, even by senior developers, to be honest. You must store your API key on the backend app. And what I mean by this is, so you don't ever store your API key on the front end where it is exposed, because the thing is that when you store your API key on the front end, a hacker could maybe hack through your system and expose your API key, and the front end should never be communicating with the API provider. That communication needs to happen from the back end, and the reason is that because the back end is never exposed. So if someone did manage to crack your front-end API or decipher it in some way, it will never see the API key because it's not exposed to the world. It's not exposed to the World Wide Web. And it will never be able to do anywhere damage. It may be, do some damage on the front end. Maybe it may look your app on the front end look dodgy or whatever. But it can't expose the API key. It can't get access to the data. So this is where we call the backend proxy. And the backend proxy is where you store your secret, you store the API keys. And this communication between the backend and the API provider is the crucial part. This is what we call the backend proxy. So any communication, anything that happens is always on the backend. Nothing can touch this, unless the deployment system or the deployment server exposes that, which is a crazy scenario to even think about. So this is how it should look like. The architecture where the front end, the user browser for example, it makes a fetch request to the backend, the app, and then the backend makes another API request to the API provider, right? And it gives it its secret. Here's my API secret. Here's all the things you need to prove to you that I am who I am and I have access to this information. And the provider says, okay, your API secret key checks out. Here is the data. So the backend API nodes, as is this one here, the Node.js server, but it could be any server, whatever you're using. It says, okay, I have the information. Now I will give this information to the front end, but it never gives the API key, secret key to the front end. The API key always stays within the back end and it communicates between the back and the API provider. But that API key, the secret right here, always stays there. It's never passed on to the front end. And that's the crucial part. Now, this is normally by default by most systems, depending what you're using, like Node.js, but you'll be surprised that some of them don't really implement this from the start. So this is something just check out. It's an easy fix. It's not difficult. And just tell the API or the AI to just ensure that the API key is stored in the backend and it's using a backend proxy, and it should be taken care of. And if you do all these 3 implements, it should look something like this, right? This is how the architecture blueprint should look like. This is the front end, the API, the browser, whatever. This is the backend. We are using the backend proxy where the secret is stored. So as you can see, the secret, everything is correctly set up. And then we also implement the exponential backoff where we do the limited retries, the smart retries. So it communicates to the external service, which is the API provider. So then also we use the pagination, which is where we identify the cursor ID or the cursor token attached, whatever they call it. But so we are increasing performance with pagination. We are ensuring that our communication with the API provider using exponential backoff is secured, so we don't ever get accused of DDoS attack or some sort of spam hacker. And then on top of that, we are protecting our API keys by using backend proxy. Doing this, you have ensured the resilience of your app, you have ensured the security of your app, and you have ensured the performance of your apps. Now, there are many implementations you can use, but these are the 3 main implementations that you need to watch out for, right? The backoff, the cursor, the proxy, right? If you can just focus on the resilience of your app, where you are controlling the rate limit by using smart retries, you are controlling the pagination, increase the performance, and you are using the backend to store your API keys, you've covered 90% of all issues that could occur within your API and any issues within your app. And you have just vibe coded like a real dev mostly. This is what I used to do backend. Now I do this and I tell AI to take care of it. I don't need to worry about this, and you don't have to worry about this as well. Anyway, I think I've covered the gist of it, and this is what's going to separate you from a broken app to a great app that can scale along the way. So if you like this video, give it a like, give it a subscribe. Hey, if you want to leave me a comment, I'm accepting of that as well. So thank you for watching. Take care. Bye.